Welcome back to Khang Tutor. Ever looked at a pizza, a car wheel, or even just drawn a simple circle and wondered, how did we figure out how to measure this perfectly round shape? It seems so simple now, but the journey to understanding circles is a story thousands of years in the making, filled with brilliant minds from ancient civilizations. Today, we're diving deep into the fascinating history of the area and circumference of a circle. Let's travel back in time, way back to ancient Egypt and Babylon around 4,000 years ago. These early civilizations were masters of practical geometry. They needed it for everything. Imagine trying to build the pyramids or lay out farm plots after the annual Nile flood. They needed to measure land, calculate the amount of grain in a cylindrical silo, or design circular foundations. Accuracy wasn't just for math class. It was essential for survival and prosperity. They noticed a fundamental relationship. For any circle, the distance around it, the circumference, was always about 3 times its width or diameter. The Babylonians used a rough approximation of 3 for pi, while the Egyptians, as seen in the Rhind papyrus, used a slightly more accurate value of about 3.16. It wasn't perfect, but it was a revolutionary start for calculating circumference and area for their architectural and agricultural needs. The real game changer came with the ancient Greeks. They weren't just satisfied with good enough approximations. They wanted pure logical proof. Enter Archimedes of Syracuse, a certified genius. Around 250 BC, he came up with a brilliant method. He imagined trapping a circle between two polygons, one inside and one outside. He started with hexagons and kept doubling the number of sides. The more sides the polygons had, the closer their perimeters got to the circle's actual circumference. Using this exhaustive method with 96-sided polygons, he proved that the value of pi was squeezed between 3 and 1/7 and 3 and 1071 streets. This gave us the famous approximation 22/7, which is incredibly close to the true value. So, what are these formulas we use today? First up is the circumference, the distance around the circle. The formula is c equals 2 times pi times r, where c is the circumference. Pi is that magical constant approximately 3.1 for 159, and r is the radius, the distance from the center to the edge. Think of it like this: if you walk all the way around a circle, you've walked a distance of a little more than 6 times its radius. Next, we have the area, which is the space inside the circle. The formula for that is a equals pi times r squared. Archimedes also helped figure this out by imagining slicing the circle into countless tiny pizza-like wedges, then rearranging them into a shape that looked very much like a rectangle. The height of this rectangle was the radius, and its length was half the circumference. This clever trick showed that the area was equal to pi times the radius squared. Fast forward to today. Have these ancient formulas lost their relevance? Absolutely not. They are more important than ever and are woven into the fabric of our modern world. Think about engineering. When designing engines with pistons, gears in a clock, or tunnels for subways, engineers rely on these exact formulas for precision. In technology, the data on our CDs and Blu-ray discs is stored in a spiral path on a circular surface. Calculating storage capacity involves the area formula. Astronomers use these principles to calculate the orbits of planets and the size of distant stars. Even in your everyday life, from figuring out how much pizza you're getting in a large versus a medium, to designing a circular garden, the circumference and area formulas are at play. They are a timeless piece of human ingenuity, connecting us to the earliest mathematicians who first gazed at the moon and sun and wondered about the secrets of the circle. So the next time you see a circle, remember the incredible journey of discovery behind it. It's a story of human curiosity, perseverance, and the quest for knowledge that spans millennia. Thanks for watching this deep dive with Khang Tutor. If you found this interesting, don't forget to hit that like button, subscribe for more content, and share this with anyone who loves a good story from the world of math. See you in the next video. Hey everyone, and welcome back to Khang Tutor. Have you ever looked at a pizza and wondered who was the first person to figure out how to get the most pizza for their buck? I mean, how do you even measure a circle? Today, we are diving deep into the fascinating history of two of the most famous formulas in math, the circumference and area of a circle. And trust me, it's a story full of ancient geniuses, mind-bending puzzles, and a number that goes on forever. So let's travel back in time, way back, over 4,000 years ago, to ancient civilizations, like the Babylonians and Egyptians. These guys were brilliant builders and astronomers. They needed to measure circular fields for farming, design round temple pillars, and track the movement of the sun and moon. They noticed something incredible. No matter how big or small a circle was, the distance around it, the circumference, was always about 3 times its diameter. The distance across, they were onto something huge. They didn't have fancy calculators, just ropes and sticks, but they got remarkably close to the magic number we now call pi. The real breakthrough came from a guy who you might have heard of, Archimedes. This ancient Greek rock star living around 250 BC wasn't satisfied with about 3. He wanted precision. His method was genius. He imagined trapping a circle between 2 polygons, one inside and one outside. He started with hexagons and kept adding more and more sides, going all the way up to a 96-sided polygon. It was like trying to fit a square peg into a round hole, but with way more sides. As the polygons got closer and closer to the shape of the circle, he was able to calculate a very accurate range for pi. He proved it was between 3 and 1/7 and 3 and 1071 streets. This incredible work laid the foundation for the formula we use today. Circumference equals 2 times pi times the radius, or c equals 2r. But what about the area? How much space is inside the circle? The ancients had rough ideas, but again, Archimedes came to the rescue. He imagined slicing the circle up like a pizza into tons of tiny slices. Then he rearranged these slices into a shape that looked almost like a rectangle. The height of this new shape was the circle's radius, and its length was half the circumference. Since we know the circumference is 2r, half of that is just r. So the area of this rectangle-like shape is its height, r, times its length, r, and what do you get? Pi times r squared. And there you have it. Area equals r. It's elegant, it's beautiful, and it all started with a guy imagining a pizza cut into a bajillion slices. So why do we still care about these ancient formulas today? Oh, they are everywhere. Engineers use them to design everything from car tires and gears to giant tunnels and space rockets. Architects use them to create beautiful domed buildings. Computer scientists use them in algorithms for graphics and data analysis. Even your GPS uses these principles to calculate distances on our spherical Earth. Every time you play a video game, watch an animated movie, or even just listen to music on a CD or a vinyl record for you old souls, you're experiencing the legacy of Archimedes. From ancient fields to modern technology, the quest to understand the circle has driven human innovation for millennia. It is a perfect example of how curiosity and a little bit of math can literally shape the world around us. So next time you see a circle, whether it's the moon, a cookie, or a Ferris wheel, give a little nod to the ancient geniuses who unlocked its secrets. It's not just a shape. It's a symbol of endless discovery. Thanks so much for watching. I hope you had as much fun as I did. If you enjoyed this journey through math history, don't forget to hit that like button, subscribe to Khang Tutor, and ring that bell so you don't miss our next adventure. See you in the next video.